Good morning, everyone.
Good morning.
Morning.
We got 1 minute. Anyone got any quick questions before we begin today? Is everyone awake before we begin today?
Yes.
Yes.
Thank you. Yeah, I got a thumbs up. Thank you, Chantel. All right, so I see that it is 8 o'clock. There's that link one more time. And daily quiz is now activated. Daily quiz is now activated. So consider the function. Actually, I'll share it to screen so we get the recording. Consider the function f of x is negative 2x cubed plus 3x squared plus 11. Which option best describes the end behavior of our function f of x? Which of these four options gives us the end behavior? What are our tails going to look like for the graph? I'll give y'all 8 until 8:03, which is a minute and a half from now. All right. So we got 50 seconds left to decide. So we've got 17. We're missing 4 people. Just missing 4 responses. Now 2. Just missing 1. Give y'all 15 seconds. Actually, we got everyone in now, so I'm just going to give y'all a heads up. I'm going to lock it in 5. In case you want to change your answer. 3, 2, 1. Locking now. And good job. Good job. 71% got the correct answer. Right? It is this choice. As I'm traveling to the left, I'd be going up. As I travel to the right, I'd be going down. So the way, again, just a quick reminder, we always determine end behavior is by finding the highest degree term. So finding the degree of the polynomial, in this case, it is a cube. Okay? Cube means that my ends are going to go in opposite directions. That's what we saw in our chart. That's what we see with all odd degree polynomials. So they're going to go in opposite directions. Normally, if it's just x cubed, right, we think as we travel to the right, we go up. As we travel to the left, we go down. It might be confusing if I don't know if my video is mirrored or not, but follow more my words than my hands. However, we are not just considering an x cubed, we are considering -2 times x cubed. So as I travel to the right and as I keep using larger and larger positive numbers, I cube it, which still keeps me with positive numbers, but then I multiply it by a negative. Positive times a negative becomes a negative, and that's why we're traveling down to the right. Okay? As I travel to the left, so as I plug in more and more negative numbers, a negative number cubed is still negative, but when I multiply it by this -2, that is going to turn it positive. That's why we're going to be going up towards positive infinity as we travel to the left. So that's why it's this selection. If it was an even degree polynomial, that's when we have both of our endpoints either going to positive infinity or negative infinity. Okay. So again, really happy 71% of y'all remember this. So that's good. Especially if you did not get it correct. Please give me a thumbs up if you understand it. If not, ask a question. Overall, thumbs up if you're good and we can move on. If not, ask a question. As well. All right. So today we are covering the next section, which deals with dividing polynomials. I think this is section 4.3. Memory serves me correctly. No, not 4.3. Sorry, don't want to confuse y'all. But deals with polynomial division. Okay, so we have two ways to divide polynomials. One you have through polynomial long division. The other way is through synthetic division. Now, polynomial long division works just like your normal long division with numbers. Instead of working with positions, you work with position of the number. So like the ones, tenths, hundredth position of a number, you work with the position of the polynomial. So the constant, the x term, the x squared term, the x cubed term, etc. So this is going to be a real test to see who has watched the videos and who hasn't. But I want you to calculate x squared plus 2x to the first plus 1. I want you to divide it by x plus 1. I'll give you a hint, there is no remainder for this. So I want you to do that polynomial long division that you're supposed to watch and learn about before coming to class today. So I'll give you all a second. Technically, you can solve this one without doing polynomial long division, but if you don't use long division at first, use it to inform your answer. That's the hint I'll give you. Set up. All right, got 3 responses so far. We do 4 now. Awesome. Some people did watch the videos. Yay. Well, I hope some people did watch the videos. 5 responses. 6. Yay. Good responses so far, everyone. All right, just for the sake of time, so we can make sure that we're moving along, I'm going to give y'all just another minute and a half. So at 8:10 is when I'm going to lock answers. It should give you enough time to finish it up and type in your response. Again, these questions are to help me gauge where we're at as a class. Give me your best guess. So I at least know who is, who isn't, or how many people are getting it from the videos and how many people need a little bit more explanation while we're here, okay? So give me at least your best guess. All right, 20 seconds. Let's see who took the quiz and left. Got it. All right. We'll lock answers here in 5, 3, 2, 1. Locking answers now. So, looks like most everyone got it. Again, you can kind of do this without doing polynomial long division. That's the reason why I chose it. But that's just so you could check your final answer. Okay. So polynomial long division, like I said, is very, very similar to your number long division. What I'm always going to do is say, okay, look at what I'm dividing into, which is x squared plus 2x plus 1, and look at what I'm dividing by. And the highest degree terms is what I want to match up. So I look at my x, and I want to turn it into an x squared because I'm going to subtract x plus 1 times this magic thing that I'm going to pull out, and I'm going to subtract that from the x squared plus 2x plus 1. So what do I need to multiply my x by to get to x squared? Someone please unmute themselves and tell us.
X.
Yeah, just need to multiply by an x. So I'm going to take that x, multiply it by an x plus 1, which will give me an x squared plus an x, and I'm going to subtract that from x squared plus 2x plus 1. Oops, I don't want to do it in blue. It's like how we do with our old number long division that it's probably been a little while since you've seen. But again, the reason why I chose to multiply x by x is so these x squareds will cancel each other out, because I'll take an x squared and I'll subtract an x squared. So I'll be left with 0 x squares, but then I got to look at 2x minus x. Well, if I take 2x and subtract an x, that gives me just an x left over. And then, just like with our number long division, we drop down the next digit, but we're not dealing with numbers, we're dealing with polynomials, so I drop down the next term, which means I drop down this 1. So I get an x plus 1. And now I need to figure out, okay, what do I need to multiply this thing I'm dividing with, x plus 1? Well, what do I need to multiply that x by to cancel out with this x right here? And it's a nice simple answer. What is the number? What do I multiply x by to get back to x? X times what gives me x?
X.
Not x. Don't even have to think that complicated. But thank you for
1.
1. Yeah, thank you for guessing the way. All I need is a 1. Because 1 times anything doesn't ever change to anything. So I want to multiply this term, x, by 1. So I'm going to need to multiply by 1. So that goes up in that top. That's what I'm multiplying by. Then I'm going to subtract a 1 times x plus 1, which is just x plus 1. I subtract those two things, I'm left with a 0. So what the polynomial long division tells me is this is my remainder. Once I've gone through all my terms in the polynomial I'm dividing into, the thing that's left over at the bottom, usually a number, could be also another polynomial, is a remainder, just like when we were using long division for numbers. And then what is up here, all those terms that I picked to multiply by x plus 1 start canceling out with terms from the x squared plus 2x plus 1. That is my quotient. And there's different ways you can write the answer for this. All I care about is that you can identify quotient and remainder. So for this division, x squared plus 2x plus 1 divided by x plus 1 has a quotient, and that quotient is x plus 1 and has a remainder of 0. Okay, there's different ways you can write how these combine back together. You'll see it as the remainder theorem in the videos. Really, all I care about is that you can identify what is the quotient and what is the remainder from your division. The polynomial long division just follows your number division, follows the same process. We're just exchanging out numbers with polynomials. And like I said, instead of caring about the placement of the digits, we just care about the terms of the polynomial. So your ones, your x squareds, x cubes, and so on. However, polynomial long division, it's a good process to go through. It is not always the best process to use, especially if I'm dividing by a linear term. Usually, if we divide by a linear term, we like to use something called synthetic division. Okay, so next question is going to deal with synthetic division, but I want to pause right there real quick, and I want to ask, same thing as always, thumbs up if you're feeling good, ask a question if not. All right, I'm actually seeing a lot more thumbs up than I did yesterday. Respond means more people are here. Awesome. So synthetic division is next. So I'm going to activate a new problem. So you're going to now see it up on the screen. So use synthetic division to find the quotient. So I just want you to figure out what the quotient is from the division of 4x cubed minus 3x squared plus 3x minus 1 divided by x minus 1. Let's use synthetic division to find the quotient from 4x cubed minus 3x squared plus 3x minus 1 divided by x minus 1. Kara, do you mind muting yourself? I think you just forgot to mute yourself again a moment ago. Thank you. Yay, the world that we are living in. It would be interesting if we had a mute button in class, like in-person class. All right, so let's go ahead and set this up. So again, I just want the quotient. Definitely see that some people watch the video from these answers. They're just not sharing answers. I'm just wanting the quotient, not also wanting the remainder. I do love the fact that it's based on the answers, people did watch the videos. Loving that. Good job, y'all. All right, again, just so we're moving on, base number of responses I got, I'm just going to give you all just under a minute and a half. So at 8:22 is when I'm going to lock the answer. So you got a minute and 20 seconds now to finish typing it in. And again, one more time, I'm only asking for the quotient. Only asking for the quotient. I do not need the remainder in this problem. We have 30 seconds left. Seconds left. Actually, much less, 15 seconds now. Again, at least give me your best guess. 5, 3, 2, 1. Locking answers now. All right, so overall you did get the full answer based on the responses, so quotient and remainder. But again, what I kept trying to ask y'all is I just wanted quotient. So for those of you who wrote that 3 over x plus 1 or x minus 1 in your answer, it is part of the entire division, but that is the remainder divided by your factor. Okay? Remainder divided by what you're dividing by, which is not what was requested in the problem. Okay? So make sure you're reading directions, especially when you're doing the homework. But that probably indicates that you did synthetic division correctly, which is more of what I care about. So synthetic division says, well, if I kind of look at and I study polynomial long division long enough, really all that matters is the coefficients. I understand the x term, x cubed, x squared, x, there's a 1's term, whatever. Those are always going to be in a particular order, so I can always depend upon that. Okay? So all I need to do is write out the coefficients of the polynomial I'm dividing into. That's what I just underlined in blue. I'm going to write them right here with some space. 4, -3, 3, -1. And then I'm going to be using a particular number that comes from this term that I'm dividing by, this x minus 1. However, the number I'm going to use is what? What's the number that I'm going to use for the synthetic division? Yes, that.
1.
Yeah, I'm going to use 1. So if I set this term equal to 0, this tells me what the root would be for that term, which is 1. Because really what synthetic division is allowing us to do is to test for roots. But x minus 1 being a factor and x equals 1 being a root are the same think. There are two different ways of looking at the same object. So what we put here is a nice, good old 1. And synthetic division has this nice little process of we first drop down the very first number that we see. We're going to get a 4. And what we're going to see overall is the numbers that we get through our process right here. Those are going to be the coefficients or the quotients. And then we usually like to write a nice little box under that very last number. So under that -1 here. And that is going to give us what the remainder is. So now the process that I go through is every time I drop down a number, I'm going to then go up and multiply by my factor, my root. So I kind of go up and to the right, and every time I go up and to the right, just essentially moving over one position, I multiply what my root is. Well, this time it's a nice easy 1. So what is 4 times 1?
4.
4. So then right below that -3, I'm going to write a 4 because I took 4, multiplied it by 1, it gave me a 4. And then I take this -3 and I take that 4 and then I just add them together. So I can write a nice little invisible plus sign here. -3 plus 4 is a what?
1. Positive.
Thank you, ladies. Gives me a +1. And then I want to move over to the next position. So I'm going to move up and to the right. And every time I move up and to the right, I got to multiply by the root that I'm testing, which is a 1. Well, 1 times 1 is just 1. So there goes a 1. And then again, I'm going to add those two numbers in that column. Well, 3 plus 1 gives me a 4. And then again, I keep moving up and to the right until I run out of numbers. When I move up and to the right, I multiply by my root. In this case, it is a 1. So 4 times 1 is 4. And -1 plus 4 is 3. So this is synthetic division. This is that process of synthetic division that you watched in the videos. And what we are looking for in this problem is just the quotient. So what was the quotient of this? Well, as I told you, right down here in this blue, that 4, 1, and 4 are the coefficients for my quotient. And how I figure out, okay, well, once I go from coefficients back to a polynomial, there's a couple ways you can think about it. The easiest way that I have found for some people to remember it is just start with the farthest right term. I can actually draw an arrow. That is not the remainder. So that 4, and that is your coefficient. So it was a +4. And then if I move one number to the left, where that 1 is, I go from my coefficient to my x term. So then this will be a +1 times x. And then I move next one position over, well, I go from an x to an x squared term. It'll be a 4x squared. And if I had more numbers, I would keep traveling to the left, and it would be my x cubed term, my x to the 4th term, my x to the 5th term, and so on. And I can just simplify this down to 4x squared plus x plus 4. So 4x squared plus x plus 4. That is my quotient from the synthetic division. And like I said, most of y'all spotted the remainder. Ooh. Wow, I feel like I'm spelling that wrong. Probably am. No, I'm not. Oh well. That's why I get for second guessing myself. But the remainder for this is 3. It's whatever that number is that you're left over. And if you're trying to write the answer, which most of y'all did that you see in the videos, which is absolutely fine. I'm just going to try to write it in green, box it in here. what you're saying is this 4x cubed minus 3x squared plus 3x minus 1 divided by x minus 1 is equal to my quotient. So 4x squared plus x plus 4. And then I need to add to it 3, my remainder, divided by what I was dividing. Okay. So that is the correct equation for the entire division. So if you did that, you're still correct. I just, again, what I was trying to get y'all to pick up on was I just wanted you to answer what the quotient was in this answer. Okay. So I'm stop talking for a moment. Allow y'all to give me a thumbs up if you're feeling good. If not, I need a question from y'all. Please let me clarify. We're going to be doing more synthetic division. We got 5 thumbs up. Okay, now 6, 7. Okay, people are here. Okay, people are here. It's more what I care about. So I'm not hearing any questions. All right. So we're going to have a new question up on Poll Everywhere. Thank you, Chris, for still giving me that thumbs up. So go back to Poll Everywhere for me. I'm going to share on Zoom as well, just so we get it for the recording. This time, I'm asking you what is the remainder from the division of x cubed plus 4x squared plus 5 divided by x minus 3. What is the remainder from x cubed plus 4x squared plus 5 divided by x minus 3? You can use polynomial long division or synthetic division if you want on this. Either will give you the right answer, though I recommend that you use synthetic division. Oops. Stop sharing before I go to the other screen. There we go. Not 4x cubed, just x cubed. And be careful here. Because when you go through synthetic division, you got to make sure you include that x term. The coefficient for the x term. Just based off one of the answers, again, I'm only asking for remainder in this case. What is the remainder? I'm just going to give y'all till 8:36, which is a minute and 15 seconds from now. To finish it up, type in your answer. Because I want to get time, because I want to show you that you can do it both through polynomial long division and synthetic division. I'll also kind of give a side by side why we kind of prefer synthetic division whenever we're dividing by a linear factor. All right, 10 seconds and we'll lock responses. Please type in your best guess. Please type in your best guess. 3, 2, 1. Locking answers now. All right, so again, for those that responded, the 11 of y'all that did, we're missing 5 still. Not sure if they just stepped away or just confused. Either way, we're about to go through it. The answer, I believe, is 68. So most of y'all got that correct. Again, the division by your factor, that x minus 3 that a couple of y'all put in your answer, that is not the remainder. That's just part of writing up that formula. Okay, so all we cared about was that number that was left over, that 68. But like I said, I want to show you both ways, just in case you want to choose one over the other. But the reminder I gave y'all at the very beginning is we want to make sure that we include the x term. However, we don't see it there, right? I just see an x cubed plus a 4x squared plus a 5. That means the coefficient for the x term made it disappear. Thus, the coefficient has to be 0. So I'm always going to make sure that I include any missing terms of the polynomial, and how I do that to make sure it's the same thing. It's just I take a 0 times that missing term. So I can rewrite that x cubed plus 4x squared plus 5 as an x cubed plus 4x squared plus a 0x plus a 5. And that means if I'm looking at my coefficients for my synthetic division, it would be a 1 for the x cubed term, a 4 for the x squared term, a 0 for the x term, and a 5 for my constant coefficient. And then underneath that constant term, I write the box because that is where I know I'm going to find my remainder. So let's do polynomial long division really quick. Again, like I said, I want to match up the highest degree terms with what I'm dividing by into what I'm dividing into. So I want to take my x and I want to turn it into an x cubed, which means I need to multiply by an x squared. So then I take this x squared and I multiply it by x and that minus 3 by that term x minus 3, and I subtract it from the polynomial I'm dividing into. So if I take x minus 3, multiply it by an x squared, this means I'm going to subtract an x cubed minus a 3x squared. And again, we chose that x squared in particular, so those x cubes will end up canceling each other out. Then I'm left with a 4 minus a negative 3x squared. Well, that minus a negative turns into a positive, which means I'm left with a 7x squared. And then I will bring down my next term, which is a plus 0x. Okay. Yes, it feels weird to write a 0x because we're not really used to writing the zeros out anyway. This is more of just a placeholder, make sure we don't make any silly mistake. Okay. But then the process is the same. I need to take my highest degree term from x minus 3, which is just the x, And I want to make it into a 7x squared so that when I subtract them, they're going to cancel each other out. What does that mean? I need to multiply x by to get to 7x squared. Someone please unmute themselves and answer, or type it in the chat. What do we need to multiply x by to get to 7x squared?
Seven X.
Yeah, thank you. 7x. So I'll need to multiply it by a 7x. That's what's going to allow me to match up. So then I'm going to be subtracting that 7x squared from taking this term 7x, multiplying it by an x, but I also need to multiply it by that minus 3. Well, 7 times 3 is 21, which means this is going to be a minus 21x. So now those 7x squared terms will cancel each other out. And then I have no x's. I'm going to be subtracting negative 21x's. Well, subtracting negative 21x's turns into adding 21x's, which leaves me with just 21x. Let me erase some of this stuff to declutter. And then I make sure I drop down my next term. So I dealt with the x squared terms, and I dropped down the x term. Move over, and now I'm going to deal with the x term, and I'm dropping down the constant. So this will be 21x plus 5. And then same story. I need to match up the highest degree terms so that they'll cancel out when I subtract them. I need to multiply my x by a 21 to get to 21x. So this means I need to multiply by 21 and then subtract 21 times x minus 3, which means this will be a 21x. And I got to figure out, okay, well, what is 3 times 21? Well, 63. Which means I'm going to be subtracting a 21x minus 63. Let me rewrite that 6. 21x's cancel each other out. I'm going to have a 5 minus a negative 63, which means I'm adding a 63. Thus, I get a 68. So again, I've now gotten rid of all my terms, all my x terms. I'm left with just a single number. That 68 is my remainder. My remainder is always what's left over. My quotient is all that stuff up here. So it'd be an x squared plus a 7x plus a 21 with a remainder of 68. Okay, so that's through it with polynomial long division. But synthetic division is a little bit quicker, right? Especially if you just went ahead and did synthetic division right off the bat. You probably didn't take as long or half as much time as I did explaining polynomial long division. This is part of the reason why we like synthetic division, but we're going to see both of them come out to be the same answer. The question that I want to ask you, though, is what is the root that I need to use for synthetic division since I'm dividing by x minus 3? What is the number that I'm going to need to put here?
3.
3, yeah. Thank you. More people responding this time. So I'm going to need to put a 3 there because that is the root that corresponds with the factor x minus 3. But then I do that same process that we were talking about. Drop down the first number. And then I need to keep moving up and to the right because I want to keep moving to my right every position. Every time I move up and to the right, I need to make sure that I multiply whatever that number is down below by my root. So this time it's now multiplying by 3. So I take a 1, multiply it by my root, which is a 3. And 1 times a 3 is a 3. And then remember what we're doing is we're adding those rows together for synthetic division. Well, a 4 plus a 3 gives me a 7. And then I want to move up and to the right again because I still got more numbers. Well, every time I move up and to the right, I got to multiply by my root, which is a 3. 7 times 3 is 21. I take 0, add 21 to it, I get 21. And then I still have one more term to work with, that 5. So I move up and to the right. I take 21, multiply it by my root, which is a 3. 21 times 3 is 63. And we see 5 plus 63 is 68. And then what that synthetic division tells me again is that these are the coefficients of my quotient. And this 68 is my remainder. Well, notice it's exactly what we got because the coefficients are a 21, which we see right here for the ones term, a 7 for the x term, and a 1 for the x squared term. Okay, so that's just showing the correlation, but for the question, we were wanting the remainder is 68. The remainder from division is 68. Okay. So, any questions so far? If not, give me a thumbs up. Same deal. Hey, a lot more people are responding this time. Awesome. Awesome, awesome, awesome. And responding right away. Cool. I think we actually got all but like one person to give a thumbs up. So that one person who didn't, please ask a question if you got it. All right. So last question for the day. Because one of the reasons we love synthetic division is that it allows us to quickly divide, right, as we saw, versus polynomial long division versus synthetic division. Synthetic division is much less writing, much cleaner, and much less time. But it also gives us a lot of information because if that remainder is 0, that means whatever we're dividing by is a factor, and that factor is also a root of gives us the root of the original polynomial. So, first question I want to ask y'all is to use synthetic division to divide 2x cubed minus 5x squared plus x plus 2 by x minus 2 and figure out whether or not it is a factor, i.e. figure out if the remainder from this division is 0. So it's 8:47, so we don't really have too much time to just like stop, let y'all try to work on it, make sure you got it before, and I kind of confirm when we go through the example. So I'm just going to do it for us. You're welcome to work along, passively listen if you want to try this on your own. So we want to use synthetic division, and that means I need to write out the coefficients for the polynomial I'm dividing. So a 2, a -5, a 1, and a 2. And since I'm trying to divide by an x minus 2, that means the root that I'm looking for is a positive 2. But then I do my synthetic division, drop down the first term, which is a 2, and then every time I go up and to the right, I multiply it by my root. So I take a 2, multiply it by a 2, this gives me a 4. I'm just always writing these arrows as reminders, and that little plus green arrow as a reminder of what I'm doing. You don't have to write the yellow arrows up and to the right if you're feeling comfortable with synthetic division. Just a side note. But again, I add the columns. So a -5 plus a 4 gives me, whoops, I don't want to be in green, a -1. I move up and to the right, which means I multiply by my root that I'm testing, which is a 2. So -1 times 2 is a -2. Well, I take a 1, add a -2 to it, I still get a -1. I move it up and to the right, which means I multiply it by a 2, which means this is going to be a -2. And at the very end, -2 plus, or 2 plus -2 gives me a remainder of 0. Okay? So is this thing a factor? The answer is yes. Because the remainder is 0. So overall, what this is telling me is that when I take that polynomial, 2x cubed minus 5x squared plus x plus 2, not only is it evenly divisible by that term x minus 2, that means x minus 2 is a factor of it. I can factor out an x minus 2, and what I'm left with is my quotient. And I get my quotient from those numbers along the bottom. So this would be a 2x squared minus an x minus a 1. So again, this is why we love this synthetic division, because it gives us a ton of information just from looking at those numbers. And if I took the time, I FOIL or distributed all this stuff out, I'll see that when I take x minus 2 and multiply it by 2x squared minus x minus 1, then I can recover the 2x cubed minus 5x squared plus x plus 2. Now the next question, which I really don't have time because we're already over, is to then find all the roots for this problem. Well, the reason why we care about this and we start with cubics and then go to synthetic division is I already know what one root is from that x minus 2 term. So I already know of all my roots, one of those is going to be positive 2. But then after that synthetic division, what type of polynomial, and I'm underlining it in red, what type of polynomial am I left with? Starts with a Q.
Quadratic.
Yeah, thank you. I'm left with a quadratic. And you all have the tools to find the roots of quadratic functions. I'm going to assume y'all are just ready for me to stop talking because it's 8:51 and I'll answer for you. And the answer is yes. All right, I can use quadratic formula. There will be 2 other roots potentially for this thing. I just need to figure out what they are, and they come from this quadratic that's left over. And that is something that we know how to find roots for. So, same thing, thumbs up if you're feeling good. If not, please, please, please ask a question. All right, so I'm going to stop the recording.